soon.
I think we should wait for her.
Yeah, yeah. Caleb told us to 30 minutes, and then I put this 40 minutes because he told me at 9, and then because of that, I was just speaking with Caleb.
Okay.
I'm waiting. Okay. Now I'm seeing me, and then that's me. Oh, okay. Yeah. Can you see my screen? Let me just to see here. Um, what do you are planning? Should I wait for Tina just a few minutes, or could we start it and when she comes, she present? Okay, I'm kind of lost here.
Hello, Melissa.
Hi.
Are you able to control the screen?
Yes, yes, but I was asking about if we should wait for Tina, or I should start.
Oh, please start.
Okay, okay, thank you. Okay, um, I will present some results. Instead, I put the information about the Holy Project here, the title, but I'm trying to resume here. Our project is, as all of you know, was very, very good explained by Dr. Abad, and then Caleb, and then the other colleagues as Vincent. Um, so we are working together with 12 countries, and then we are 14 institutions, and all of us working together with in long-term experiments data. So information. So we are planning to access information about the how this how time could uh, impact in carbon soil persistence. So this is very, very interesting when we have so many long-term experiments and so many long-term data sets, and then together with the modern tools So let me try to here. Yeah, here are the institutions first. And then here, just a few tips again for our colleagues. So each researcher will present a concise update of the activities or tasks in each country and focusing on major milestones and challenges, key findings if we already have, next steps for collaboration. Uh, why I'm speaking if we have key findings because I think the first main step is organize and harmonize data set in the repositories. This is very um, even is we already have the data. This is very very hard to do because we have lots of data. So this is a huge, not a big, but huge challenge. Uh, Here I put another information, kind of a list that I was thinking uh, to follow. So starting with me, and then from France, Hungary, Estonia, South Africa, Ghana, New Zealand, Norway, Germany, Uruguay, Canada, and a close discussion. I don't know if all the colleagues will start with us today, but yeah, I will. We will see. Um, from the Brazilian side, I think the main challenge is obtain the information or help to colleagues to put information in repositories. We started this project with 40 long-term experiments, uh, and together from the Brazilian side and the foreign colleagues. Uh, for the Brazilian side, almost I think all of us, all the experiments are from Embrapa. So as employees, we must to put our data in Embrapa's repository called HEADUP. And uh, from the colleagues from abroad, we are using Zenodo repository. So we agreed that we will have the two repositories having a copy, like working as a mirror each other. So we started from with Zenodo. We already have 10 data sets. Just this is just from abroad. The colleagues from Canada, France, Ghana, South Africa. Let me see, Estonia, Hungary. I think it's just New Zealand. I think from abroad Brazil. We are just waiting for Uruguay dataset. They are having some concerns, but I think soon they will put the data there. And then from Brazilian side, we already have 11 data sets. It's different yet. So we have 21 data sets. It's just half of we started thinking that we will have, but I think as a data set and from historical for long-term experiment, So this is very, very, uh, uh, it is a challenge because the researchers already have the data, but they have no time to proceed this. This is hard because the researchers, almost the researchers has the data in her or your own um computer, personal computer. So I think I'm very happy to have 21 data sets in for the colleagues' work. I'm sorry. Here is in a blank because, as David said, told for you yesterday, we are just starting because before this team uh, start to work, we have to have the data set at least a good, um, I forgot the word in English, I'm sorry, a good union of informations um, from different sites. We have to have this in the repositories, and then we need to harmonize this because um, each country has their own methodology. And then, because of this, at the beginning of the project, we agreed that we would uh, do, or we would proceed at least one soil sampling, and then we use the same protocol. This protocol is we already have. This is um, in being revised to under review to be published. And then we have protocol for methodologies and protocols for data use. So both are under review. And then let me see. Another thing we are, as a information for the how we are proceeding. Another thinking we are together in the project is about the podcasts in Work Packages 3 and social media that Caleb presented yesterday. And then this is just um, a script about the structure of our podcasts. And then I hope at the end of this workshop, we have a list with the colleagues who would like to present, because at the beginning we were planning that we would be very, very good if we produce at least one podcast per institution, and then organizing and these activities. So as you can see, it's a not a big podcast. We could have a podcast of until 10 minutes, 9, 8 minutes. I think if 4 podcasts is a good information, and then for presentations, a huge time, especially in the nowadays. The people likes the information come very fast. Otherwise, the people, how do I say, accelerate the voice. So we need to be um, very concise and objective. And we are thinking how to proceed especially for this new generation. So I hope to have help from the younger researchers because I think the people, these colleagues, maybe, I don't know the word, dominate the new tools for proceed this. So I think until the at the end of this workshop, we could have a good plan, a good list that we agreed the how much podcast we could produce. And then just information here about the some past events of this year, where we presented some information from the project. And then we had a soil carbon research symposium that held in Rio de Janeiro, here in Brazil. And we had more to biochar 4 in Colombia, and Eurosoil last month in Spain. If maybe Tamash could speak some information about this. And here, just to close my presentation. Here we have some social media address. We have we are in Instagram and X and LinkedIn, and we have a homepage that I am put a new information. I was doing this yesterday, but I need to stopped. But I have a lots of pictures from yesterday to put there. And if you, all of you, put information on Instagram or on one of these, please put our name there. And then we could repost. Okay, thank you very much. And then I would like to call the next colleague. Let me see who will be here. Next is Dr. Abad Shabi from France. If he could, just one more thing while Dr. Abad started about the extension. I think I remember right now. I forgot to put my presentation. We are asking for 1 year extension. We are requesting
of CA on CA on mostly organic carbon. So again, we mostly organic carbon. So again, we observed increases in organic carbon of up to 14% within no-till systems. Carbon of up to 14% within no-till systems compared to conventional tillage. There's also high conventional tillage. There's also higher particular POM, as well as improved fulvic and humic acids within CS systems. Again, this manuscript is under review. Hopefully, we'll get review. Hopefully, we'll get response soon enough. So this is what we've done so far in South Africa. So our students, the PhD students are still ongoing. MSc students are finished. PhD students are still ongoing. MSc students are finished, and we hopefully because normally the PhD students have been sampling seasonally. So far, they've already sampled for the current season seasonally. So far, they've already sampled for the current season, and they will be busy in the lab over the next few weeks. And I think that's all we have from South Africa. And we also think that's all we have from South Africa. And we also want to thank our funders for this. Thank you so much.
Thank you, Adonis. Oh, great. Thank you very much. I'm very happy to see, to know about the that we have so many papers published, and that we have so many papers published, and so many under review. So I think I will provide you maybe a Google form for. I will provide you maybe a Google form for sharing this information, uh, or to send to me, because this is very very important to have a kind of register of this, because as we are so many, it's very easy to lost this information. So since our project started 2023, and we have 2 years, so if we didn't doesn't organize this, it's very easy to lost information. So I will provide this form for you. Thank you, Adorns. Let me see the next one according my list here. It's Vincent. Hi,
Okay.
Vincent.
Hello, Melissa. How are you?
Hello, I'm fine, very
Great.
fine. And you?
Nice
And you
seeing you
all?
online. I thought I'd be seeing you in Ghana this time around.
Okay. I would like to see to be with you this time, presentially, not virtually, but
Okay. Thank you very
thank.
much. All right. So I want to give a brief update of our work in Ghana. I tried doing this yesterday, so most of you are very familiar with my slides. But Caleb hit me that I have to still do this again today. So I was trying to give him a little bit of no, but okay. So in Ghana, we have about 6 different sites across the country. And as you're already aware, these are the African Dark Earth site in Ghana. So please, can you show my slides? Okay, all right. Okay, so each of these African Dark Earth sites were selected in 6 locations. And at each of these locations, we had a look at other land use types. And then we have field in Mole National Park. We have field also at Asantequa, which we'll be visiting on Friday or Thursday, I think so. So in Ghana, we selected about 1,000 soil samples. So in Ghana, we took 1,000 soil samples across these areas, which are very hectic. Handling about 1,000 soil samples is a lot of work. And I must also acknowledge our pedologist, Thomas, for holding the fund for the students. Let's give him a clap for always on field trip with our students. So for the Ghana site, we have almost completed all the analysis, and this is very good news for us. And then we also have a second work in Norway, because Norway didn't receive funding from the funders. So we have to take that up with Germany. So Joshua did a number of samplings in Norway in the snow. And then he took about 160 soil samples in these areas. And I must be happy to say this work is about 95% complete. And then he still wants to do some few analysis on iron and aluminum oxide. So for the 2 PhDs, we are happy to say they are the thesis writing phase. Most of them have finished their lab work. They are just writing. And then the 2 MPhil students, they are 3 actually. Sorry for the mistake. One of them submitted a draft thesis for review, which is under consideration. And during the period, we received an MPhil student from Brazil, from Embrapa, together with Tevino. She did a very important work trying to look at the humin and the humic substances of this African dark earth. And then this will be run to get the isotopic signatures, and very important for this part of the work. So this is more or less chemical fractionation, unlike the physical fractionation that we are doing. So we published a paper recently in soil user management, and Emmanuel Joshua has drafted a paper that will be published in Helion. It's under review. And of course, we have a number of manuscripts also we are working on. So you can see some of the profile pit here in the African dark curve with very thick horizon, and these are purely anthropogenic. And then as we refine these practices, we want to encourage most of the farmers to do a number of work which will also increase the persistent carbon pool. So I showed this yesterday. You can see some of the African dark earth site here, and then you can see a maize crop going very well on this African dark earth with little fertilizer application. You can see Emmanuel Bedu in the photo there taking a field sampling. So we did also outreach programs at one of the communities in northern Ghana where we trained farmers to prepare compost, and there are about 120 farmers. And also, we also established a 10-acre plantation of tree crops. So what we did was we procured the seedlings from Forestry Research Institute of Ghana, and these were given to the farmers to plant. And I'm happy to say most of their trees have really, really established, and they are quite very happy with this. Now, I want to be a little bit brief on presentational results, because the student will do this more. Joshua will come just 2 people after me, and then he did a number of vulnerability studies in the laboratory where he subjected samples to decomposition after a 98-day period. And then you can see that on day 1, there are differences in carbon dioxide evolution from these soils. But surprisingly, after day 1, if you move to day 3, day 7, and to the rest of the days, there were no differences that you can see. And then if you look at this production system, it is purely fodder production system. It is a rotation. So you can see that each of the rotation is 4 years. But then after 3 years of rotation, you will see the soil from those plots having very much emission of carbon dioxide, and it is quite difficult to interpret what could be the cause of this. Because where you have a lot of grassland, you may want to see recalcitrant carbon, but we see more carbon being evolved after 3 years of further production. So I want to conclude that overall the project in Ghana is very much on course. We have made a lot of progress with student work, and also with meeting a lot of stakeholders in terms of conference presentations across the globe. And also the students are at the writing phase of their work, and we also putting a pressure on them to publish and submit their thesis with time. Initially, we were of the view that we may not need the extension, but as we just all agreed, we definitely have to also go for the extension. Then we go along with the consortium. And then we have also uploaded our historical data on time. We were one of the first institutions to upload our historical data. And I'm also happy, Melissa is also very happy about this. And then for our new data, we are almost complete. And then very soon we may be uploading also on the Zenodo platform. So thank you very much.
Thank you very much, Vincent. Yes, you were the first to put data there. Thank you for this. And thank you for your presentation. Very, very good. About the farmers, it's a lot of farmers. I'm very impressed about this. So many people. And it's just a question. I saw that was in one city, But those farmers, they were in the same community. They live together around the same place. Vincent?
Yeah, it's a farming community. So before we were there, we announced our coming. So the chief had to organize the farmers, and then we trained them at their school, their primary school. So they came together, and we offered the training for them.
No, so beautiful work.
Thank
Congratulations.
You. Great.
Thank you very much. Next one, David.
Good morning, Melissa. Good morning, everybody.
Good morning.
Great pleasure it is to be here in this room in Ghana. And I'm sorry, Melissa, you're missing out, but it is a great time we're having here. I would like to take this opportunity to thank the organizers for making this happen. And it's great that we are able to come together. I'd like to update you on what we have done in New Zealand specifically. And I apologize perhaps if it might be a little bit sort of data dense, but I hope very much that if I run through it quickly, it will be of value to see what we've been doing. I just want to remind ourselves, and I've been quite heartened at this meeting here, there's not been a lot of talk about building carbon stocks to mitigate climate change. I mean, when I was part of the 4 per 1,000 group a few years back now, it was very much that we could, of course, solve climate change by increasing soil carbon. Well, it can contribute, but it is never going to solve the climate crisis. And our focus, and everything talked about today, is very much on building sustainability of our agricultural systems, not solving the climate crisis. We must be aware of that. So, and also, I think the point here of these quotations, I leave you to read, but these quotations are that it has often been assumed that increasing soil carbon stocks will increase productivity. That's not always the case. We have to be careful to make these general assumptions. But also the major point here is that retaining carbon is important, but carbon has got to break down in order to release the nutrients and help the microbial processes. We can't just lock off the carbon. We've got to make it available. So that's just reminding us about those. Just a quick note about New Zealand. We're a small country. We're a small island, quite different from where we are just here, really. But most of our agricultural land, of which is 53% of our land, is in grasslands. That's the dominant feature. So our focus is on grasslands, really. We've got high
land over there. I couldn't go deeper. I remember when is land over there. I couldn't go deeper. I remember when Isabel asked me, which depth are you going to sample? I was talking, 0 to 100, and she was talking, 0 to 100, and she was laughing. She didn't, I'm sure, laughing. She didn't, I'm sure she was saying it in her head.
Kind of freezing.
Sure she was saying it in her head.
Kind of freezing.
Yeah. This guy didn't know what he's talking about. But when I go to the field, I realize why she was shaking the head. So this is one of them. You go a little deeper, you meet a rock, so you have to dodge. You go a little deeper, you meet a rock, so you have to dodge, and then make sure that you scrap everything, then you go deeper. So this is one of the issues seriously encountered on the field. So my report, when you will see it, that is the reason I couldn't go to the 100 centimeters as stated in the protocol. And so after the sampling, the soil samples were oven dry at 40 degrees Celsius because at that time we're in winter, so I couldn't get the normal sun, so we have to resort to oven drying. And then the other one that looked like a pilot, over there was when I was milling the plant samples which were collected. And so when the samples were brought back to Ghana, because NIBIO, they didn't have well-established laboratory where we can do it, so I have to ship it back to Ghana, to the soil science laboratory here in KNUST. So the laboratory analysis took place. So this plate shows when I was doing the fractionation. Yes, so that is the picture there. And so after the fractionation, these were the samples that were obtained for nation. These were the samples that were obtained for the particulate organic matter, which were run to obtain the particulate organic carbon. And so with the physical parameters that we have analyzed so far, include the bulk density, the porosity, and the specific surface area, and then the particle size were also determined. With the chemical properties also, the EC, the pH as stated here, were all analyzed here. And with the fractionation also, we have the mineral associated organic carbon and then the nitrogen obtained, and then the particulate organic carbon and nitrogen we also analyzed using the CN analyzer, which also provided us with the ratios as well. And thanks to Isabel, my Norwegian mother, she also provided me with the yield data and also the cover crop biomass yield that were obtained. And so the results from some of the selected, tomorrow, God willing, I'll give update on the most of the results we've obtained. But for the want of time for today, I would like to state some of the results that were obtained. Here we have the particulate organic carbon, which were also high, mostly across the grass land or grass plot. So when we pick the mineral associated organic carbon, look at DAI, the third year grass. It gave a highest mineral associated organic carbon, which I'm tempted to believe that, yes, grass also help with the stabilization or with the carbon improvement of soil organic carbon. But the longer it is on the field, the higher the contribution of organic carbon. Because when we look at this data, we have grass which are 1 year old, another 2 years, and a third year. But when you compare these three grasses, the third year grass was given high organic carbon compared to the rest. And also the bulk soil nitrogen were also obtained, and the same trend was observed. Now, with the contribution of the pools to total organic carbon, it also indicated that across all the systems, they all gave contribution more than 60%, which means that most of the carbon were stored in the mineral pool, which is a very good news for us, because we know that if we have most of your carbon in the particulate pool, within some few years, it will all get mineralized, and the crop may suffer at the long run. For immediate effect, it is good, but for the long term, it's no good for us to have more of our carbon in the particulate than the mineral associated. And with the Same trend when it comes to the contribution to total nitrogen, it also follows similar trend, which is far above 50%. So most of them were within 70 and 80% mineral associated organic nitrogen and its contribution to the total nitrogen. And so the soil carbon stocks also indicate, my professor yesterday mentioned this in his slide, that as the surface area increases, we also have the stock also increases, which is more or less like a positive correlation for us. And so with the yield also, we have the grasses also given us. Now, before that, the crops, the weight or the drying or the moisture content at which they were taking differs. So when you pick potato, for example, because it's mostly sold at the fresh state, the moisture content was about 85%. That is why I didn't include it in this graph, because when I added it, it was making the rest look not significant. So I have to reduce it for those ones who also have its way. Now, the outstanding activities that we are here to look at with the emissions. The samples have been sent to Kenya for the analysis. So they've sent the first batch from the first day to the 35th day. So we are expecting the second analysis from them, which will be from the 56th to the 98th days. And also the analysis are yet to be conducted. My boss also mentioned that we are yet to do the aluminum and iron oxide. So we are yet to do those ones too in the lab. And then we'll proceed with the manuscript writing. So by concluding, I want to use this opportunity to thank EJP Carbon Around and to my supervisors here in Ghana and those from outside, including Dr. Abad and my Norwegian mother, Isabel, for their contribution towards this. What she taught me was to say "tusi tak," meaning that thank you 1,000 times.
Thank you, Joshua. Caleb, we have some questions from audience.
Joshua, from me, a very good presentation. We'll have to look at your data and do some analysis, but when you were talking about the carbon, I realized where you are coming from, because in our tropical system, we have a lot of fire. So we tend to have a lot of our carbon in the forested area than within the carbon system. And then within the forested grassland, you also have much more stabilized carbon. But in the European system, we tend to have more carbon within the grassland. And then when you look at their buildup, it is even much more higher than what we even have within our forested system here in the tropics. So it is something you will have to sit down and then we build upon in your discussion.
Thank you.
Yes, and about the...
Hello, Melissa. Alan will
Another question.
Alan will want to talk.
Okay, thank you.
Okay, I just wanted to ask Joshua about the sampling to 100 centimeters. Were you digging with a shovel or were you using a soil auger?
I was using an auger.
Oh, okay.
Yes, please. But I dug that to demonstrate something, that there was something that was the reason I couldn't go deeper.
Any other questions?
Yeah, Audu. A question from Audu.
Hello,
Caleb,
Joe.
I don't know if.
Hello, Joe.
Yeah.
Yes. Thank you for your nice presentation. From the figures, you had land use systems, and the objective was to see differences between the land use systems. That is fine. But when you presented, means were not separated. You only presented the mean values. And when it's like that, it is difficult to compare things.
Thank you. You see, the graphs I showed on the slides, you will see that I indicated that the error bars is equal to the standard deviation. So we can equally use those things for checking the differences in it. Thank you.
The error bars can be equal to the standard deviations, all right.
Audu, what he was just doing right now was to focus on the distributions. He will be doing a proper presentation.
A trend, maybe a trend, but the error bar cannot give you the mean separation. You have to use a tool.
Yeah. Meaning you have to go
like use post hoc.
Post hoc, yeah.
Yes, to separate the means. But error bar, it's a way of showing, predicting error margins for you. Yeah. Okay.
So I think what he's going to do is tomorrow he's going to do a deeper presentation.
Thank you.
Okay. Melissa, do you have something for us?
I have just a question about how deep he dig, because I didn't catch this information.
Okay, I sampled 50 centimeters. So I couldn't go 50. To the hand. Yes, please.
Oh, yeah. Which type of soil?
It's Cambi soil.
Yeah. So it's correct.
Relatively young soil. So.
Yeah. Okay. Thank you very much. The next
Melissa
will be
Jerome will be coming. I think in about 2 hours' time. So okay, Johanna will give us more information.
Yeah, Jeroen landed, I think, about 20 minutes ago. So he will be here soon, but I think he will not make it until the coffee break. So maybe he will do his presentation tomorrow morning, if that's possible.
Yes, of course. No problem. I don't think so. Agustin or Claudia is coming, or they are not in Ghana, and I think they are not here virtually. Agustin is still. We are still organizing our. How do I say? They are organizing the information about the agreement. They are worried because they not receive funding. So they are very happy to contribute with data, but they are still not put this in agreement or addition. But I speak with EJP office. There are no problem about that. We are just agree between us. So I'm waiting for him about it, but I will try to ask to him again. So because of that, they are not be here. And Claudia, she sent information. She sent data to Zenodo repository. So we already have data from Canada, and they are working on microbiology methods, and they are discussing information and trying to provide some results. But we already have lots of results from Canada in Zenodo. So I think that's it about Canada. And yeah, I think the next step for the program, it's coffee. I think a lot of you are needing coffee right now. So I think after coffee, maybe I could start it with just pick some information about each presentation. And then I think Caleb and the team will separate the presents in different rooms, small rooms. Yes, Caleb, if you would like to give some information.
Melissa, I think for the breakup rooms, we are looking at an opportunity where we'll have a lot of us here to make it much more effective. So we've also discussed a whole lot of the things we need to do. WP1 is almost 100% done. When it comes to WP2, we are still within the primary stage, so there will be not too much to discuss. WP3 too, most of the activities we'll do in WP3 will be met here. So probably, I'm thinking in the next round, Adonis, is it possible we could execute our podcast plan for the partners here? Is it possible? And then you can participate online whilst all those things are going. We may set up a seat in front, and then we execute that particular plan. What do you think?
Sorry, my microphone was muted. I'm thinking great to discuss podcasts plan, and because I think if you were divided in small rooms, I couldn't participate. So I think here I can't. I can't. Yeah. But so great.
But if it is possible to, maybe when we come back, you can help us to maybe give us a brief information about what WP1 needs to do next, WP2, and then WP3 before we do the podcast.
Yes, after coffee.
After coffee.
Okay. Okay. So we have 15 minutes of coffee. Yes. Kayla? I can't see any of you. I'm just seeing me. So, now it's 7 a.m. here. Okay, now it's 10 to 11 for you. And maybe we can come back 11 and 5. Is it good?
So, Melissa, Ghanaian time, UTC, probably we come at 11:10.
11:10.
Yes.
Okay. So for me, 8:10.
Yeah.
Okay. Okay. I will take note here. 8 and 10. Okay. Okay. See you soon. Have a good coffee break. I will take mine too here.
Okay.
Not so good as yours, but see you soon. Bye-bye.
chosen. I know who I am. I know what you've spoken. I'm already loved more than I could imagine. And that is enough. Oh, I'm already loved. I'm already chosen. I know who I am. One thing I desire, only this house, just to dwell. This will be my posture, laying at your feet, just to dwell. Let's sing aloud, church. Dearest Father, closest friend, most beautiful, most beautiful. Dearest Father, you're our closest friend. You are most beautiful. You are one thing I desire. Only this I seek, just to dwell. This will be my posture. I'll lay right here at your feet. Oh, just to dwell here forever. We know who you are, dearest Father. You're our closest friend. You are most beautiful. Hallelujah. You are dearest Father. I know you to be your presence here, your glory here. Dearest Father, you're my closest friend. You are your glory. Dearest Father, closest friend. You are most beautiful. One more time, let's sing it, church. Dearest Father, you're my closest. You are. I know you to be most beautiful. Dearest Father, you're my closest. You are most beautiful. And there are no words. It's nothing I love says. Oh, I know words. It's nothing I love says. That's all we have left to offer. Oh, sing it loud. There are no words to describe your goodness, Jesus. Our love will sing to you. There are no words. It's nothing less. Our love will sing. Our love will sing. We'll sing. To describe your faithfulness, Jesus. You've been so good. You've been so good. We sing, there are no words to describe your consistency. So our love will sing. Our love will sing. We sing. Now somebody just lift your worship in the room. Come on. We worship you, Jesus. We worship you, Savior. We worship you, Healer. You've been a good friend. You've been a good, good Father. We love you. We honor you. We adore you. We adore you. There's nobody like you. You're holy. You're righteous. Majestic. You're perfect in all your ways. Say, there yes, in the land of the living, I fix my eyes. You're beautiful, so beautiful. If you've tasted and seen the goodness of the Lord, say, I'm so in love. You're beautiful. There's nobody else like you. You have eyes like fire and hair like wool. I'll fix my eyes on the author and the finisher of my faith. So beautiful. With just one look, everything changes. I'm captivated, and I'll never be the same. With just all it takes is one look, everything. I'm captivated. I'll never be the same. Just one, everything. I'm captivated. I'll never be with just one look. Everything changes. I'm captivated. I'll never be one more time. Say, with just one. Everything. My body was healed with one look. My mind was regulated with one look. With just one. My family was rescued with one look. My baby was cured of cancer with one look. I'll never be just one. All it takes is one. All we need is one. All we want is just one look, just one. My family was rescued. My children were saved. Yes, they were. I got all the mercy and grace that I need with just with us. My mother was healed from cancer. My grandfather was healed from diabetes. Your family was rescued from sin and shame with just everything changed. I'm captivated. I'll never be I'm so in love with you. You're I'll fix my eyes. There's no one else like you. You're beautiful. One more time, just the voices. I'm so in love. Oh yeah. So beautiful. Your grace is beautiful. Your mercy beautiful. I fix my You're beautiful. So beautiful. With just one, everything changes. Just one, everything changes. acknowledge your presence. We acknowledge not just your presence, but the power of your presence. That we can be here and come in one way. And because of your love and your grace and your mercy and your presence, that we leave changed. That everything that's attached to us changes. That our lives change, our families change, our homes change, our jobs change, that our perspective changes. Right here in your presence, our shame is removed, our guilt is removed. Our hearts are mended in your presence. Your presence changes everything. If you know his presence is a life-changing thing, would you lift up words of worship and words of praise for his presence, for his presence, for his presence, for his presence. In his presence there is fullness of joy and pleasures forevermore. In his presence there's liberty. In his presence is his spirit. In his presence there's healing. In his presence there's joy. In his presence there's salvation. We thank you for your presence. I'll never be the same with just one me. If the altar's where you need us, take me there, take me there. If you're looking for an offering, I'm right here, my life is here, and I'll be a living sacrifice for you. You're a refiner. I wanna be consumed. I wanna be tried by fire. Purified. You take whatever you desire. Lord, here's my heart. I wanna be tried by fire. Purified. You take whatever you desire. Lord, here's my heart. If your glory wants to come in, let it fall. We want it all. Lord, your fire is consuming. Fill this place. as a sacrifice. I wanna be tried by fire, purified. You take whatever you desire. Lord, here's my life. I wanna be tried by fire, purified. You take whatever you need. Lord, yes, I wanna be tried.
Hello, Melissa.
Hello.
Yeah, we are 10 minutes late.
No problem. The people, are the people coming yet? Or all of you are in the room?
Is your faithfulness to me? And I'll still bless you. Yes, I'll still bless you. Yes, I will. Yes, I will. Yes, I will. Yes, I will. I'll still bless you. I'll still bless you. Oh, yes, I will. Yes, I will. Yes, I will. Yes, I will. I'll still bless you. Oh, I'll still bless you. Yes, I will. Yes, I will. Yes, I will. Oh, great is your faithfulness. Great is your faithfulness. Great is your faithfulness. Great is your faithfulness. From the rising sun, to the setting, same I will praise your name. Oh, great, great is your faithfulness to me. Morning by morning, mercies I see.
Hello, Melissa.
You've been faithful.
Hello.
Please, you can begin.
Oh, great. I will share my screen. Can you see my screen?
Yes, we can, but the words are very small.
So let me try another way. Oops. Here. By parts. Just a minute, please. Oops. Not so big. I'm home and you are hearing my dogs. I'm sorry. I have two. And sometimes they.
Melissa is about to print, so please.
Thank you. Here, let me share. I think I will try to share right now without presentation mode. Let me see if you can see better. I don't know what I did here with my window. but you just, I'm not seeing you. Let me share what do I, okay. Ah, yeah. Oh, it's terrible. May I try using Excel file? Just one more minute. I'm sorry. Let me close here. Let me open Excel file first. I think it could be better because Excel is Excel. Now, can you see? Let me increase. Okay. Can you see?
Yeah.
Now, can you read? More important.
It's difficult still, but we can manage. It's getting better. Yeah, that's good.
Okay. Yes. Well, I will read. Yesterday, I sent for the team a new an updated Gantt Gantt file. Let me see here. Well, here. In fact, this is not the last one. I'm sorry. Let me try to open the other here. Okay, but here we have two deliverables in in the not the first, but the work package. Let me see, 0. Here, the management and coordination project. And here we have two deliverables. Agreement signed. This is almost. We still we still are missing the Uruguay, the INEA. It's just this institution is missing. If you, I don't know if some of you know directly Agustin or Andres. If yes, you could try to access this, but but if not, I'm trying to by email. And the another deliverable is the protocol for data use, flow, and security. This is under review. This is done. This deliverable is almost done, but we will publish it because of that. This is under review. So we will publish by Embrapa. So they are in process. These are in process. So I put this agreement signed for until we are in October. I hope until end of November we have this. Because we are just missing one signature. So in fact, this is very simple, but seems not so very simple. But I'm trying to. And the other, I hope so at the beginning of the next year. This is for the next step. For the work package 1, we have two deliverables. sorry. We have 2 deliverables. The protocols for soil sampling, this is done too. This was done. And we is in the same way as the first one, another protocol. This will be published. This is under review too. So we are just filling some information because we are publishing under Embrapa series. So we have some, how do I say, normas in English? I don't know if some of you know, but some rules about the form. So we need just to achieve this. So this is the same stage at the beginning of the next year for the organized and harmonized and accessible data sets. This is, we almost have this. Just a minute. Problem solved. Toy was put inside of my laptop. This is for you. This is the cause of the war here. Okay, I'm sorry. But the data sets, we, as I told you, we already have 21 data sets in the repositories. The next step is we have a colleague here from Brazil. He have a team. He is working in the Embrapa Agricultura Digital, so digital agriculture. And he has a team of students which is working on pick the information directly from Excel file and through, I don't know if Python or R software, and using some techniques from those expertise. And they will put this information in the information that are needed by the modeling team work. So we are starting this phase. So we are discussing, I think in the next meeting, general meeting, maybe our colleague Luis Barioni could update us about it. But until now, we are exactly in this point. If I'm not wrong, David was in one of the last meetings, and then I think if I'm not forget anything, we are in. So we are in this time. I think here from Brazilian side, we are still missing some data sets. So a colleague of mine who are participating of this project, and she is working with GAD emissions in paddy rice system, and she has lots of data, but she is having some concerns to have time to proceed this upload. As I told you, we have lots of this the same situation, especially from here. From abroad, as I'm not wrong, we are just missing information from Uruguay, and their site is the oldest one. It's from 1963, so it's very old. It's the oldest one in our consortium. So here from this work package, from the deliverables, we are just missing this data set. And from here, we need to proceed the harmonization, still organized, but harmonization, this data set to start to work from the next work package. And let me see here. And for this happens, or publication of synthesizing findings in meta-analysis of regional drivers of soil carbon stocks, and summarizing the findings of management practice and the vulnerability of soil carbon stocks to loss. For those things happen, we need the first step, we need the modeling team. So because of that, is the next step is focusing. I think our energy needs to be in this information.
Overcome the challenges. So if we want to overcome the challenges, so if we want to get more information on the CRM project, you can visit our website, follow us on social media, and keep an eye on future episodes for the podcast. There'll be more members participating in this podcast as we go forward. And thank you so much for being around. And until next time,
Thank you so much, Adonis, for having me. Thank you.
Okay, so our next guest is David from New Zealand. Welcome, David.
Thank you.
So I won't go into the background. I'll just go into it since we've already introduced the purpose of the podcast and the background. So David, let's start with the background. What's your research area and focus, as well as any other information about yourself.
Thank you. Well, I come from New Zealand, and in New Zealand, most of our land area which is productive is in grasslands. And my work is involved in trying to protect those grasslands so they maintain productivity. But we also retain the soil carbon stocks because we realize that's a very important component of the productivity.
Okay, that sounds interesting. And so within this project, what is your focus within the whole See Around EJP project?
So our focus is in terms of the different land uses associated with grasslands and different agricultural practices. Which of those practices helps us to retain soil carbon? In New Zealand, we have high soil carbon stocks, particularly in relation to Europe. Europe, our stocks are really very high. It's really important that we maintain those carbon stocks and prevent the loss of carbon. So we've been looking at different land uses and the impacts of those land uses on carbon stocks. And we've been doing comparisons between horticulture, between sheep and beef farming on flat land, sheep and beef farming on hill country, dairy farming, and cropping.
This looks like quite a lot of work. And from that work, what are the milestones that you have achieved so far?
We've been working with these soil samples from these different land uses. We chose 30 different soils in a region of New Zealand where the climate is very, very similar and the soil is the same type. So we were truly looking at the land use effect. There are big differences in the amount of carbon in soil under these different land uses. There are major differences in terms of the potential to add more carbon into those soils. And we've also detected differences in the vulnerability of that carbon to be lost.
And in all this work, have you faced any challenges or major discoveries?
Well, the major discoveries we've made is to be able to help us define a framework of vulnerability that we can then apply and we can take to our policy interests, people interested in policy, to help to say which areas are likely to be more vulnerable than others, which land use is likely to be more vulnerable than others. Previously, we've had a lot of information about soil type and in land use, but we've never had an index of vulnerability which we could apply at large regional scales.
And challenges, any challenges that you faced?
Well, the challenges as always working with soils is the variability in soils and being able to define the variability across a range of conditions to be able to synthesize what's actually happening. So we do need to take a large number of samples, and we do need to take samples across a wide region to come to some general conclusions.
And then any plans for the way forward from now?
Well, having done this for a small area of Canterbury, the area where I live in New Zealand, our challenge is to scale this nationally so that we can have an index of vulnerability nationally. And we are using different techniques to be able to assess the properties of the soils and their vulnerability using infrared techniques, cheaper cost options of measuring soil carbon concentrations and doing measurements more rapidly to be able to do that. And we believe that within a short time, we will be able to have a whole map of the vulnerability, and we will be able to inform policymakers about how they should be changing land use, or rather not changing land use to protect those soil carbon stocks.
I'm sure there's a lot of interest from the public in knowledge about vulnerability. How have you been sharing such knowledge with stakeholders in New Zealand?
Public is interested, yes. Farmers are interested, yes. They realize the importance of soil carbon. However, they also need to be offered incentives in order to make land use decisions, which they would otherwise not make. So there's a lot of discussion in New Zealand about how we incentivize farmers in order to adopt practices which are going to make the land more sustainable. We work through our government and our local regional councils, and they set the standards and the requirements that farmers are required to adopt in their practices.
Okay, David, thank you so much for sharing your insights, and hopefully you will continue sharing, because I think there's interest from what I've gathered on this topic of vulnerability of carbon stocks. Thanks so much once again.
Thank you for asking us. Thank you.
So now I'm joined by Abad from France. Thank you so much for joining us. All right, so may you please provide a brief background about yourself, your work, and your interest.
Okay, so my name is Abad Chabri. I'm a research director at the INRA Institute. It's a National Institute for Research, Agronomic and Environment and Food Security. And on the meantime, also as a professor at the University of Saclay, teaching biogeochemistry. Before that, I was spending almost 10 years in Germany before reaching France in 2003. So it is, yeah, I'm basically working, my background working on soil sustainability, agriculture sustainability in the context of land use and climate change.
Okay, thank you. Then, so within this project, what is your main focus?
Main focus is just I'm helping Melissa first of all to coordinate this project, as it was in the beginning, trying to bring also my small experience in improving this project, but also trying to have the best what we can provide for the funders. Of course, what I'm expecting, because it is a very challenging project, not only in terms of thematic, but also it is a cross-continent, also dealing with the countries in which we have less information and less data, specifically what's going on in Ghana, in Namibia, and all of this and then it's an added value from what we have so far, but also it's an added value in terms of young scientist training and PhDs and all of these things. So this is really my focus, and I hope that we, at the end of this project, we come up with some strong results. Yeah.
You've also highlighted some of the challenges that you're facing. That was going to be my next question. Can you maybe elaborate more on the challenges of managing such a big project and how you've been coping?
Yeah, as usual, when you are dealing with different partners, different countries, and of course, when you are also trying to build up from what is already exists, is the first challenges is what data has been produced in the past, how we can collect this data, how we make sure that this data is available, and how make sure also this accuracy of this data, because it is a standing point from what we are going to build and from where we're going to develop further in this project. This is the first challenge. The second challenge is this, of course, you plan things in the project that never happen as you plan. You have all difficulties, not only natural difficulties, pedoclimatic difficulties, but also human resources, and then also it never work from the first plan. So you have to adjust, you have to adapt, and as I said, especially where we're working in different countries. But we have to keep mind positive, and then things is going.
Yeah, that's true. We need to keep pushing and be positive.
Yeah, absolutely. Yeah.
So what milestones have you achieved so far?
What we have achieved so far? And many things. Yeah, I mean, when speaking, generally speaking, at the French level, really, it was a good opportunity because we are working on a long-term experiment. It is now started in 2005. And now we are in 2025. We have done what we call initial characterization of the system to see how much carbon we have in the beginning before implementing the experiment. And then one of the questions that we implement, at what extent the introduction of grassland within crop rotation, maize, wheat, barley, can or not help improve in the soil. So we have been, we know how much carbon we have. We know now how much is added or losing in the carbon. So we have been doing this assessment in 2005, 2014, and then with the help of a PhD student from Brazil, we are trying to assess what we have in terms of carbon based on the management we implement. And what is very important, we see that some of the unexpected results that difficult to convince a farmer is that we have some how we call information from the beginning that the grazing is increasing carbon in the system because uridang, label compound, and all of this, and it is not the case. And then the grazing is decreasing carbon in the system from what we seen from our result. But doesn't mean that these things is happening globally. Probably is a site specific, but it is a fact that we are observing based on the data that we are collecting. I think that's just to highlight, if maybe it will be in your question, and what's my expectation in the project. It is not just that every country work on its own corner and then trying to analyze, but try to have one, how we call synergistic view in which how we can pull the data together in a way we can develop some of the questions that David highlighted a few minutes later about the vulnerability. For example, from what I heard this morning from his presentation, is that would it be possible to have the same approach? And I think the same is the case, same approach in a way that we can compare this approach with the data we have in France, but data we have in Ghana from Joshua, PhD, and then try to come up with a paper to highlight at what extent the soil under the particular management is responding differently, and what make the soil responding in that case. It is something that we can we can assess the vulnerability of the system based on intensification or disturbance regimes. This is some, and it will show the project that we are really, that was the expectation of the project, that we are working collectively, hand to hand, and we're pooling the resources and the expertise instead of just every country show his own result. Of course, this is a work package dealing with the modeling in which we are going to have all of this data to run the model, to test the scenario, and this is another question, but at least we can show methodological that's something differently beside the modeling that we are foreseeing in this project.
And I'm guessing one of the most important steps for that to happen is harmonization of the data. How have you been able to achieve that harmonization of the data for modeling, or something that is still ongoing?
You mean, yeah, this is, as I said, you mean if the data is available? What?
Harmonization of the data. Harmonization of the data for modeling.
The harmonization. Yeah, this is what Melissa mentioned this morning, that it's, of course, this is, we are trying to collect this data, put it on in a different server. This is now, it is located in Brazil. But it is not that much easy, because once you have to collect this data, then you have to check this data if it is complete, if it is not complete, and then of course make it in a format that can be used for the modeling exercise. And I think that we hope that the extension of the will take place, because this is really what we need. We are reaching the 3rd year in May of the project, and it will be a pity not to really to have this extension in a way we can test this data and run the model, and specifically some of the scenario that we promised in the beginning of this project.
And lastly, how have you been engaging stakeholders and farmers and students in France?
Yeah, I present some of the results, but I said they have some in mind, some of the practices that's relevant. Like as I said in the beginning, for them, grazing is increasing carbon. So when it comes, because it's a huge lobby in France for respect to grazing. Animals play very important, and I have nothing against, but also we have to see the animals also as disturbance regime. It depends how you intensify the system, but also with some consequences, of course, in terms of losing carbon, in terms of greenhouse gas emission. But it is a question of trade-off. We are not going to provide any magic recipe that can, in the meantime, reduce greenhouse gas, preserve carbon, but also provide food security. So this is a question, what are the expectations? Where we are going to put the cursor? We need like a high, in the middle, and then with the fact accepting the side effect, which is, we know that can be not 100% filling all of the boxes, but we have to keep in mind, and we have to accept some of the negative effect of these things. And it's sometimes for the farmer difficult to accept, and then it is a process of convincing, a process of making sure that the right way is this, but also we can reduce a little bit, but if we change altogether our mind of thinking, but our the not responding all the time to the market, and business. Yeah.
Well, thanks so much for sharing your insights. That was quite
thank you very much too. Thank you.
Okay, now I'm now joined by Joanna. Thanks so much for joining us. And my first question is to request you to give us a brief background about yourself, what you're doing, your studies, or anything that you can share on your background.
Yeah, hello. My name is Joanna Zimmermann, and I'm a PhD student in Steer-Around. So I live and work at the RPTU in Germany, but the experiment where I'm working on is in Norway. It's a collaboration with the Norwegian Center of Organic Agriculture.
Thank Thank you. So what is your focus within that project?
At our experiment, we are comparing the effects of comparing the effects of anaerobic digested slurry and untreated slurry on mainly on the processes that happen in the soil. So my main focus is to identify processes that lead to a reduction of soil organic carbon, because most of those fields have now a decrease in soil organic carbon. We would like maybe to stop that or even increase this carbon stocks again.
And so far, what major milestones have you achieved?
So last year we did some soil sampling, and we also had greenhouse gas emissions. So we can say that the results indicate that when you apply the anaerobic digested slurry, even though it had less carbon in it, the carbon in it is more stable. So that could lead to a higher soil organic carbon content in the soil. So that's one. But we also observed higher carbon dioxide emissions from these plots. So but less nitrous oxide emissions.
And I know mostly in research we encounter too many problems and challenges. Have you encountered any challenges or problems in your research?
So my personal main problem is that I live in Germany, but I have to work in Norway. But I'm not allowed to be in Norway for a long time and spend a lot of money because of their foundation. So what I do, I drive there, take soil samples, take greenhouse gas emissions, and then I come back to Germany and do the lab analysis in Germany. So, for example, in the beginning of October this year, I was in Norway and I took 200 kilograms of soil with me in the car to do a column experiment during the winter in Germany.
Yeah, that seems like quite some challenge. So, any plans for the future going forward? What are your plans?
So right now we are planning, like I said, a column experiment during the winter where we would like to compare the two types of slurry that I mentioned earlier, and we also would like to see how the climate change will affect the soil organic carbon in soil. So we are also applying two different precipitation scenarios, so one with the historical data and one modeled future scenario where we have more precipitation to see how the processes are affected by climate change.
And lastly, have you embarked on any knowledge sharing events with stakeholders or with farmers?
Yeah, we hope to suggest something to the farmers in Norway because our research is really site-specific. But yeah, we hope that with the results we are able to say that maybe anaerobic digested slurry is better for the soil organic carbon.
Thank you so much for sharing your insights and interesting challenges. Hopefully, things will work out well for you. Thank you.
Thank you for having me.
I'm now joined by Professor Vincent Loga, who is one of our hosts. Thank you so much for joining us and for arranging this wonderful workshop.
All right, thank you very much. I hope you enjoy your stay in Ghana.
Yes, it's quite interesting. Very nice campus here.
Great, great.
Okay, Prof. Vincent, my first question to you is, what is your focus within the CRN project?
Okay, the focus of our work is to look at persistence of soil carbon in anthropogenic forest islands, or what we call the African dark earth. So we do quantify how much carbon is in the persistent pool, and then look at a lot of soil physical properties as well.
All right, thank you. And so far, what milestones have you achieved?
We are also working on a Norwegian site in a long-term experiment in Nibio. So we also looking at the same parameters in these areas. We have achieved a number of deliverables. We are training a lot of students, and at the same time linking up with farmers on how to manage their soils. And we have a number of stakeholders involved.
And within all this work, have we encountered any challenges or discoveries? Maybe let's start with challenge.
Field work is full of a lot of challenges, especially when you're handling a lot of data. I remember one of our sites in Ghana, we took over 200 samples. So we have over 1,000 samples taken across these areas. And that is really, really a lot of work. And then planning a lot of field work, and then also doing a lot of community entering, trying to, have permission to enter farmers' field. It's a lot of work.
And now going forward, what are the plans from now onwards?
For now, our immediate plan is to graduate our students, the PhDs to graduate, and then the masters to graduate. And then we also do much more of stakeholder engagement to disseminate our research findings.
Yeah, that's going to be my next question on how do we plan to engage the stakeholders and share information.
Yeah, for the stakeholders, we started engaging them along the project. For example, we did a training for farmers where we tried to train them how to prepare compost using recalcitrant materials to increase their persistent carbon pool and at the same time the particulate pool. And then we hope to do that more if we have the time and the resources.
Thank you so much for sharing those wonderful insights. And
all right, thank you very much. Thank you.
I'm now joined by Alan Manyebere from Forte, South Africa. Alan, welcome.
Thank you.
Okay, Alan, can you maybe provide a brief background about yourself, what you do, and where you come from?
Okay, my name is Alan Manyebere. I'm an associate professor of soil science at the University of Forte, and in this project, I'm a partner with AR Agricultural Research Council of South Africa. So basically, I can say, in short, that's who I am related to this project.
So can you share more details on your focus within this project?
Okay, so within this project, we are looking at improving soil organic carbon. Our trials are situated in an area where there is very low organic carbon. Some would call them dead soils, less than 2 mainly. So we have established CA trials or conservation agriculture trials 13 years back with the sole purpose of building organic carbon and also looking at soil and water conservation. Yes, so in this particular trial, we have 3 factors, the tillage systems, the rotation systems, and residue management. So for this project, we are trying to look at the persistence of soil organic carbon within the systems, and also look at greenhouse gas emissions. Yeah.
Okay, thank you for that background. So what milestones have you achieved so far?
So far, I can say quite a number. So one of them is the recruitment of postgraduate students who have since graduated, 2 MScs, and we also have PhDs that we have incorporated within the project, and a research fellow as well, who has been incorporated into the project. Yeah, in terms of the results, I think we have managed to see a gradual increase in terms of organic carbon. I think some of the results that we have presented show that up to more than 10% in terms of organic carbon. Remember, we are coming from a very low base, and that little 10% means a lot. So yeah, we have also managed to have a few publications, and some manuscripts are under review. Yeah.
Okay, thank you so much for those insights. So have you faced any challenges during your research work?
Oh yes, challenges. Most recently, we have had fire destroying some of our laboratories. In fact, the whole floor of laboratories has been taken out by fire, and unfortunately for this project, we have lost quite a number of samples for one of our PhD students who was working on soil microbiomes. So yeah, that has been a major, in my view, one of the major challenges. Yeah, that has been a major challenge for me. Yeah.
Any plans to recover from this for the student?
Oh yes, we are putting in place some measures. I think it's obvious that the student will need an extra year just to cover up for the samples that have been lost, and yeah, we intend to also just like, I think the extension of the project will also assist us in that regard, so that we can achieve that particular objective.
Okay, so one important aspect of this project is engagement with stakeholders and sharing knowledge with farmers and other stakeholders. Have we embarked on any of these previously?
Oh yes, sharing knowledge. We have shared knowledge at different platforms, presentations at scientific conferences, and also our students have been engaging with farmers around the project areas, trying to sensitize them on CA systems and their benefits to the communities. Yeah, thank you.
Okay, thank you so much, Alain, for sharing those insights, and all the best as you go forward with your research work.
Thank you.
Thank you so much.
Thank you.
Okay, so as we wrap up, we've heard from various partners on what they're doing, their progress, their challenges, and their plans for the future. And we want to thank you so much for tuning in, and we'll keep on collaborating and working together. Thank you.
One quick question. When will their podcast be live, and where will it be shared?
Yeah. Most of today's podcast will be on all the see around social media, which Melissa had created. So we'll share almost all the link by the end of the workshop. But remember too that our national media like Joy News, Adom, and City FM are already picking some of these stories and already publishing them. So by the end of today, I'll be sending you links to what you did yesterday. Hi, Mr. Are you with us?
Yes, yes, I was listening the interview.
Yeah, we can't hear you.
No, my microphone is opened. No,
They are going
hearing
to work
me?
on. They are going to work on the mic for you. So
Mine?
we
Yes,
can't hear you. So she's going to work. The control room is working on your mic.
Ah, okay. Okay, it's better? I will test, 1, 2, test. No? No?
I think now we can hear you.
Yes?
Yes.
Can you hear me? Okay, thank you. The lady was talking, was Melissa, Ghanaian Melissa. Yes. Okay, thank you very much. I was listening the interviews. It's very, very exciting. I like it. Um, yes, we can share in our social media, and I'm trying to use to. We don't have yet YouTube, but I think I can create it together with our project account. So I think we can do it. Oh, I saw Jerome in the room. He arrived. Is he arrived? Yes, I can see you. Did you see? Yes, it's me here. Like that. Yes. Oh, okay. Now, uh, welcome, Jerome. Now I think, I don't know, now you are in the lunchtime, I think. For me, it's in the middle of the morning, but for you, it's a lunchtime, I think. Vincent, would you like to speak?
Hello, Melissa.
Yes,
We have
I can.
Jaron just arriving from Germany. He's here with us at the moment. Jaron Zeto from Germany.
Yes, yes,
So
I
just
saw you.
introducing to
I saw him.
the group that he's arrived safe in Ghana.
Oh, great. Thanks.
Okay. All right. So Jaron, welcome.
Oh, great. He would like to speak something about the update of the project.
Is it working?
Yes, the microphone is working.
Yeah, thank you for the welcome. Yeah, as said, just arrived, so getting climatized, so to say, because yeah, Germany it's now already getting winter, so a little bit different temperature. Yeah, but I'm looking forward to the discussions here this week. So, thank you.
Oh, great. Are you coming from Germany and being like, how do I say, that vegetable that we are onion? We are taking off the clothes in the way. So back into the podcast. I think after we can share these by our social media, and at the same time, I will try to put it on YouTube, because there I think we have a way to do it. But yes, at least from social media, and each a picture or anything else, what you providing on social media, please put our dot there from See Around, and then we can repost and reshare your information. And from now, Caleb, the program, now I think you are just a little bit late for the lunchtime. Yes, let me see the program. Yes, according my version of the program, I think that's it. Am I your microphone? Let me see if I. No, I can't hear you.
Hello.
Yes.
Oh, okay. I
Thank
think
you.
we are now up for lunch for about 40 minutes, and then we come for the lecture and the demo from selected participants from Ghana.
Oh, great, great. 1:30. Okay.
I hope you'll be having yours online.
Yes, I will. I will be here. Thank you very much for you all. Have a great lunch. See you soon. Thank you.
Provoking Posso me volar bem aí, não. Não pude nem não, não tive não, não sei qual é o que Yetina malu changu na mawange, mambo manginga mi pongo. Amapata magoso baloma kwan, ikumbula misaka yingo woni. Nandan mene chene na longisimo, mamu mwajo mukolo kukamba. Asawadi walambo wetide ya mitango, bomane bola kipanda dala wanyango. Imani, imani. Bambambe obedimo, bashengi kao, windi mabu winderi, palo indeko. Yende lamba yende nchikalambo, yende malantikolo kukamba. Yetina lamba sinongo, ine laune mama tumbe lamba, una one sinne lamba. Mambo mambe wanyolo, melonika, masio mabala doyo, nasangwa boy. Imani, imani. Bambambe go bedimo, basenginika, wendi mobu wendedi, follow me they go. Yende lambo yende nchikalambo, yende malantikolo kukamba. so smooth, trying to keep my cool. I can't help myself, you make me act a fool. Sweet thing you say, the sexy way you move. I get so excited, babe, I don't know what to do. I really wanna be your only one. Forget about the rest. Why stop with good enough when you can have the best? Really good, what I'm trying to see. I want you to stay, I'll stay with you. Baby, don't stop doing what you do. What do I say? Johnny, I do that. I want you, my bully, morning. The jingle, I'm the my late time, my mouth is still go. You better take a friend. Get the money to a longer. Let me come on. Mon name is Eva Winge. Mon name is Masi Van Mon chica, we are tell the number. Mon name is Mama. Just to show you need to stick with me. I can be more than you know. I'll be your best friend. Hold the hand, yet my the knowledge can, baby, everything you need. But you can find it in me. The kusibam sima nana bentona. So na muna vinchagi, but you got long I'm fully all your singer now. We don't know people who got say nana dina wamutana. Don't stop. somewhere. Alachibana was singer. Otimbi. Otimbi so. Alachibana was singer. Otimbi so somewhere. Oh no.
What's up, Leverkusen? Thank you very much. So good to be back here. I'd like to introduce this wonderful, beautiful, cute, good-looking, sexy band. Oh, yes, we are. Alexandre and Jean on trumpet. Mika Lecoq on keyboard. On drums, he comes from Monaco. I know, it's fancy, right? Every time you mention Monaco, ooh, la la. Ooh, la 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 la. And that's Nicola Vicaro. And this gentleman comes from one of the most dangerous places on earth. Don't be scared. He's the only nice guy on that area. It's called Napoli, Italia. Italia, la mafia. Romana. And of course, thank you. And from Leverkusen. You know, when I saw the series I was going through this fall too, the manager sent me this list of the cities I was going. I saw Los Angeles, I saw Singapore, Tokyo, London, Paris, and Leverkusen. And this is my favorite. I eat good food here in Leverkusen. Yeah, I get kartoffel. Last time I played here? Really? Don't tell them 20 years. Get out of here. Tell them it was last week. Don't. People say, now people come to me, Mr. Bonner, I discovered your music through my father. I'm like, I used to like you, not anymore. You're not my friend. Now she comes here, I saw you last time here. This is long time ago. Don't keep telling people. It was 2 weeks ago, not 20 years ago. No, I don't remember 20 years. 99999. Do I look the same? Thank you. Wunderbar. Juste le volume un peu, s'il te plaît. We're not going to play a ballad for you guys. And pay attention. Because this ballad needs some attention. And whoever finds the title of this song will win a Richard Bonner t-shirt and a hat. Yes, so pay attention. After the song, if you give me the title, you're the winner. Because I like to test my audience sometimes to see if they're really slick. Don't go to Shazam. Thank you very much. So what was the title? No, that was the end of it. That's the winner. Beautiful. Beautiful. Where you from? Aschaffenburg, right? Okay. You see? Dreamland is called. Yeah, check it out. You see? That's one of by Jacko. You see? You guys don't know that one, right? Now you know. We're now going to play a song by a guy called Richard Bona. Thank you very much. And this one, I wrote this one when I went to India, very first time in India. I'd never been in India before, 2006. And I landed in Mumbai. Wow. So many Indians. They were everywhere. Love it. End up writing an amazing song, very inspiring place. And this one is called Shiva Mantra, which means in your language, Shiva Mantra.
Kojate kiti kojate odi kuno Bine koseje odi kuno Opiana koko mene hokaide Kojate kiti kojate odi kuno Bine koseje odi kuno Opiana koko mene long
Thank you. We're now going to play Ting Town. Oh, yes. And this one is definitely by Jaco Pistorius. And how are we going to start this one? You know what? Start something from your village in Monaco.
Dankeschön, Leverkusen.
We're now going to play a nice little bolero, a very quiet song. And this one is called Mute Sukudu, which means in your language, so smart. Banatano Mute Sukudu Nalde Nasita na bene nonde Mwende yenda kaleti Banatano Mute Sukudu Nalde Nasita na bene nonde Mwende yenda kaleti Timbi no go kauna bene Monde no veri no betue Jinove deni Wasingin ni cowboy Lungan mo lenita Na timbi no go kauna bene Monde no veri no betue Singing the Nicaragua, longer more than the Nica.
Natimbino kokano Monde nove ni nove tui Wasinyene ni kamwe Longe mole de nika Natimbino kokano Monde nove ni nove tui Singing any cowboy, Lungamo, and the Nika. Was singing any cowboy. Longemo, Lendenika. Thank you. So now, I feel like dancing now for real. Are you guys ready to dance? I can't hear you. Are you ready to dance? So everybody, those who are sitting down, everybody up, we're going to dance now till 4 in the morning, okay? Let's go. Ready? Woo!
jumbelande. Mabama wingi mande. Tokusale wandelende. Monti bien ça sont bon. Let's dance some Makossa now. Nicola Vicaro on drums. Nick Carocca on keyboard. Alexandre Richon trumpet. My name is Richard
Hello,
Bonner. Thanks so
Melissa.
much for coming.
Hi, Melissa. Okay. Hello. We are now on the lecture and demonstration section where we will be looking at regenerative practices on its impact and innovations. on soil carbon and greenhouse gases. We are supposed to have started with Dr. Alfred Atta, but he had some emergency in Accra, so could not make it to this particular section. But it is still very interesting that we are going to have Dr. Kofi Kunedu Boaten. He is coming from a specialized area in the sense that he was with us, but now he is with the founders. So we want to get both perspectives as he presents about a 20-minute word for us.
Okay.
Not really. Just I have to make some notes about just to introduce the session. It's okay. I hope that you are not sleeping after this heavy lunch. You need a coffee maybe. It works?
I think the standing one.
Okay, I said, yeah, good afternoon. So I have been asked to chair this session, but before we started, at least can give you some of the highlights, what we are talking about, and then why it is important, and then just to set the scene, yeah, in order to animate the discussion. So first of all, I would really highlight that, of course, when you're talking about the regenerative agriculture, we have to keep in mind that soil represents one of the largest active carbon pool on land, and that means those improving soil carbon stock offer a significant mitigation pathway. This is one thing, this was important things. And the second thing that we have to keep in mind also the term of regenerative agriculture, so what we are talking about, and it is often referred or used to describe a farming system that goes beyond the sustainability, aiming not just to maintain but also to restore soil biodiversity, ecosystem function, and carbon. So this is one we use about the regenerative in a way that we are having a kind of win-win situation, gaining and taking profit from the system, but also in the meantime providing a kind of system that can be continuous and for the negative, but also for the positive way. So many agricultural soil, or as you know, not only in European countries are depleted in organic matter. In Europe, we have basically 1%, and then compared from what they have in New Zealand this morning, I heard that they are losing carbon, but they are far away from losing all the carbon that we have already lost in Europe. So it is, and then of course in Africa, but also in North Africa, due to many of these problems. First of all, the climate change itself and the erosion, but also misleading practices. So depleting organic carbon, as I said, tillage, crop residue removal, intensive practices, but also climate change. So that means if we are aiming to restore the soil organic carbon just for two reasons. The first one is to improve soil health. It's another concept that soil health, that the system aiming to provide the services, resilience to drought and flood, and of course nutrient cycling and also carbon sequestration to remove greenhouse gas emission from the system. So regenerative agriculture or practices may also reduce greenhouse gas emission. As I said yesterday and this morning, there will be or there will never be a magic recipe and a way that you have a perfect system, especially in agriculture, because we need food, we need to ensure the food security, but it is, I think that is, it is now almost accepted by many countries, including the United Nations, that the only system continue to increase or to provide or to release greenhouse gas emission is agriculture. So we have to have a kind of compensated system from other parts of the system that can also reduce or compensate from what we are losing from the system. That means we have to improve the soil management, we have to reduce the disturbance, we have to restore the nutrient use, but also the magnetism and performance and trade-off need to careful evaluation. So we need to have an assessment and evaluation, but also in a way that we can adjust the system. But it doesn't mean, and I have to repeat myself, the magic recipe will never exist in agriculture as far we want to ensure the food security and also reduce greenhouse gas emission. So I think that I'm not going to take so much time, so we have to show some of the example for regenerative agriculture practices for soil and carbon greenhouse gas emission. There is many of the example over the world, and if it works in well place doesn't mean it works in other place, because as I said yesterday, is a site-specific, region-specific, and then we have to adapt your system based from what you have in terms of. So this is many of the word that is been used to fulfill the regenerative agriculture. And for example, many of the use what we call the cover cropping, multi-species cover cropping, or at least introducing grassland intercrop rotation within the different time scale in a way that we can, what we lose in agriculture, we can compensate in bringing this carbon again into the system. And it is not always very easy. Losing carbon is very easy. Bringing carbon to the system, is another part of the business that needs always very forceful, but anyway, it is part of it. So we need to reduce the tillage. Many places the tillage may bring some of the added value and some positive, but not always the case. And then, for example, it works maybe in tropical area in Brazil, that's reduced tillage may bring some fruit and some, but it would never work. And in Europe, for example, such a practices has been abandoned because it doesn't improve carbon stock, and then even it was given some not the exact information of carbon stock assessment, because you build this a very tiny area in which you compact the soil, because the soil is not completely plowed, and then you develop you concentrate carbon only in a few centimeters. It doesn't give you the real value on how much carbon. So it is one of the practices that has been abandoned, particularly or no tile or reduced tile. Basically, that now not 30 centimeters, but between 20 centimeters and 25 centimeters, but it's still almost plowing system is going on. The crop rotation and increased carbon diversity, crop diversity, it is also one of the practices that has been postponed by European Commission. Now we are not anymore allowed, since for 3-4 years it was in the former BARSO, it is not allowed to exist. I mean, after harvesting, you leave the crops, the system for 3-4 months into the net crop, and then by doing things you lose a lot of carbon. But now such a practice is not. We need to have the soil completely covered with some of the kind of vegetation in a way that we can reduce. And most importantly, it was also stressed by the European Union, but also many, France in particular, but I think in Germany, what we call the the crop diversification or multi-species in a way. You can have grassland, you can have also legume, but also gramínea and mesa. It poses some of the problems in terms of harvesting, but also in terms of pest treatment, but it is a way how you can also improve the system in a way that, of course, you reduce also the amount of nutrition. If you mix the legume and and gramínea, you have the nitrogen transfer, but also you improve the quality of the organic matter, which is also has an effect, as I said yesterday, in terms of greenhouse gas emission, because you may have reduced the nitrogen oxide emission, but also the fluxes in the system, but also increase the biodiversity, microbial composition, but also earthborne management. So I have been talking about the integration of crops and livestock, but also the trees and shrubs. It depends, and we use in many places integration of crop and grassland into crop rotation, but also in some other places they use shrub, but also integration, for example, in Brazil and some other places they use this thing. But of course, the integration of livestock and cropping system, grazing and the new plow, it not always was successful, because we have had this experience in our long-term experiment. When we plowed the grazing system for 6 years, we lost a huge amount of carbon, because due to the label compound we have in the system, but also in the system itself, when you put animals in the system for the six years, we don't never increase carbon. Instead, we're losing carbon, because animals, they add a label compound and stimulate microbial decomposition and then releasing carbon in the system. So you see, sometimes you have to test. It works in some places, but not in every place. And last but not least, of course, we have to improve, or we have to apply the innovative amendment versus soil carbon enhancement technology in a way that we can increase the amount of carbon by using, for example, biochar. It also has been improved in many places, but not always very successful. It works in places, but not. So we have to adjust your system, enhance the weathering by, for example, by applying across silicate rocks, or to improve the system, or to soil to accelerate chemical uptake of CO2, because it is silicate has been also used in many places as a carbon sink to absorb CO2. But also we need to, and then I think we've been yesterday talking about the in the round discussion about the AI, the artificial intelligence, that really can be used in this case, not for generating papers, but also for calculating, but also applying to tell you what is the best way, how you can measure the evolution of carbon stock, but also monitoring, improving the monitoring, and also improving the report and verification, MRMV, and of carbon changes. And thus enabling scaling the quantification of residual practices. Another problem, and here that when we talk about the practices, if it works, this is always what we practice in Europe, but also in agriculture. It works when in one place you get a very successful, you say, wow, it works, we are happy, but when it comes to upscale this practice is another problem. You have to have the all ingredient in a way to upscale and make sure that what you have observed in your area, in your region, is scalable and also make it successful. So this is some of the keywords I wanted to share with you in a way that we can stimulate some of discussion. I am sure that it is not complete, and probably you have other information and other idea on how we together we can come up with some of the solution in a way that we can put it into practice. Thank you.
Thank you very much, Abad. it will be interesting for you to share your slide with us. We like the point.
With you. It is just because Johanna told me you have to jump. I said, okay, I have to leave my lunch and jump here.
Yeah. So, about your chair is there for sure. Oh, okay. Oh, okay. So, our next presenter will be Dr. Frank Aidan.
Good afternoon. My name is Frank Aidan. From the Department of Animal Science, K University. This afternoon, I'm trying to see if I can say something on the greenhouse gas emissions. Looks like everyone here is a soil or crop man. And I'm the only animal here. Yes. So if the crops are not there, the animals, we are in trouble. So if you are doing your things, please consider us because we need your crops to survive. All right. So I'll be looking at some few practices that can help to reduce greenhouse gas emission. So this will be my outline of the presentation. I'll go straight to look at some few points, and then I come to look at the innovations and then the practices that can help to reduce the greenhouse gas emissions. Now, the population of the world is growing very fast. As a result, we need to provide food for the individuals who are growing, who are being given birth to every day. It's estimated to have about 9 billion of people in the next few years. All these people have to eat. And food is not only plant. And it means that we need to try and then supply animal protein, especially in the developing countries. Once the middle class is growing and the incomes are growing, there's dietary shifts and people are demanding more of animal protein compared to plant protein. So because of this, there is a lot of intensification of farming, and that is one of the major reasons why we are having issues with the greenhouse gas emissions from livestock. So this growth that we are talking about has resulted in higher land use and water use and increased greenhouse gas emissions. Here we are looking at gas like carbon dioxide, nitrous oxide, and methane, with methane being the most potent of these gases. So the impact of the livestock growth will be on soil health, deforestation, global warming, air quality, water pollution, and environmental sustainability. So if you take soil health, for instance, you want to keep animals on pasture, and then as they graze, they can cause overgrazing, which can result in the loss of the topsoil through erosion. So the major greenhouse gases that are of importance have been estimated by different agencies, with our Intergovernmental Panel on Climate Change, FAO, EPA, and all the others, estimating these emissions from livestock to be between 8 to 18%. So that is quite a lot. So out of these gases that I mentioned, methane is the most potent of them, and it has a lot of concerns when we talk about greenhouse gas emissions. And it is estimated to be more than 25 times that of carbon dioxide. And this is due to the fact that there are different animals which contributes to methane production. But the livestock that of importance are the ruminants, with cattle being the most animal with the highest emissions of methane. So the direct methane that are generated by cattle or other ruminants are from two sources. The first source is enteric fermentation. So during the digestion process, there is fermentation, and this results in the production of methane. And this is normally due to the fact that if the feed is of poor quality, you are going to have a lot of the fermentation products being converted to methane instead of being shifted into propionate, which can be used as energy source for the animal. The other is also on manure management. So the way we manage our manure can also result in the release of methane into the atmosphere. So for enteric fermentation, if we look at ruminants, unlike monogastrics, they have a rumen which is capable of breaking down or fermenting fibrous materials. And as a result of this fermentation, there are some microorganisms within the rumen which we call the methanogens. And these are able to convert hydrogen and carbon dioxide into methane. So the more you have methanogens in the rumen, the more you are likely to produce more methane from the animals. And once the animals belch or defecate or release any gases, this methane can be released into the atmosphere. One of the major problems will be for animals that are grazing, especially those that are moved from one place to another place on poor quality roughage. And these animals hardly receive any concentrate or highly digestible materials, and that results in production of more methanes. So the production system is one factor that affects methane production. If animals are housed or in the intensive system and provided with concentrate or highly digestible roughages or forages, the amount of gases released in terms of methane is quite low compared to animals that are grazing on poor quality roughages. But in terms of production per animal, the dairy cattle, because they consume a lot of feed, they have higher methane output. But for beef cattle, which are normally grazed on poor quality, per feed consumed, they release more methane compared to daily cattle. The other way that can also contribute to the release of methane is how manure is managed. How manure is managed. And methane from manure is normally as a result of anaerobic decomposition of manure. And these are normally manure that are stored in lagoons or slurry tanks or pits. If they are exposed to anaerobic decomposition, then you will likely to have the release of methane. But most often, if they are allowed to be decomposed using the composting procedures, then they are shifted from methane to carbon dioxide and then nitrous oxide, which is quite manageable compared to the methane. So in terms of nitrous oxide, it is the third gas that is of concern compared to methane and then carbon dioxide. Now, as the concentration of the nitrous oxide increase in the atmosphere, it can affect the stratosphere, and then that can result in imbalances within the radiation on Earth. So research has indicated that the presence of nitrous oxide in the atmosphere can result in formation of acid rains. And that is one of the things that we want to avoid. But for nitrous oxide, even though the effect is not too sudden compared to methane, it has a longer span in terms of its storage in the atmosphere. So if we allow the gradual buildup of these gases in the atmosphere, they can cause long-term problems for us. So mostly the nitrous oxide released from animals are from manure management. If manure is improperly managed, for example, during nitrification, it can result in the release of nitrates, and then during denitrification, the anaerobic microbial conversion of nitrate into nitrogen gas can result in nitrous oxide, which is an intermediate of the process. Even though this is smaller compared to that of fossil fuels, as I said, if they are allowed to accumulate over a long period of time, they will be of a challenge to us. So we have to try to avoid the continuous release of these gases into the atmosphere, which might eventually cause long-term problem with the climate change. So for nitrous oxide, if the manures are not managed properly, and then there is nitrification, it's going to result in the release of these gases into the atmosphere. Apart from these direct sources, there are also indirect ways through which methane and nitrous oxide are emitted into the atmosphere. So for methane, indirect causes normally result from decomposition outside the controlled storage systems, even though it is not as much as that of the direct methane emissions. They are also very important, and they can result in overall increase in the methane footprint. So here, the key pathway that we have to look at is to how to manage manure. And here we are looking at how manure is what is applied onto the soil, because improper application can lead to the release of nitrous oxide. So when you have waterlogged areas, when you have soils that are that contains a lot of water, and these manure find their way in there, because of the anaerobic nature of the place, they can result in release of these gases. So there are methods of estimating these gases. It's quite complex, but I'll try to just give a brief overview of that. So for methane and nitrous oxide emission estimation is quite a complex thing. So there are different ways that we can try to estimate these gases. But before you can do that, you need detailed data on the specific type of animals that you are using, including even the diets that they consume. So you have to compute for feed intake. You have to check the digestibility of the feed. So here, if you are looking at the feed composition, you have to look at the protein content of the feed, and then how digestible this feed are. Usually, diets that are highly fibrous are difficult to digest, and that is what usually creates the fermentation issues that result in the release of methane. So the management system is very important, whether they are on the extensive system or intensive system as well as the local climatic conditions. So for methane, there are usually two pathways that they get into the atmosphere. One is emission. If you want to calculate, that would be an emission from the digestion process. So the enteric fermentation is one of the major problems when it comes to methane release from livestock. And then the other is what? The manure management. But for nitrous oxide, it's mostly as a result of how we manage manure. And in terms of this, we are looking at how manure is stored, whether they are liquid or they are solid. They determine the amount of nitrous oxide to be released. And then the application method that is used on the soil, whether we just dump the manure on the soil or we compose the manure before we use that to fertilize the soil. So in terms of estimation, we normally use the IPCC method. We have tier 1, tier 2, and tier 3. Okay, in Ghana here, we are trying to use the tier 2 method to estimate. The tier 1 is quite simple, but the tier 2 is something that takes a lot of effort. Because one, you need to know the subcategories of the animal. So even with cattle, you have to categorize them into what? Into beef cattle and then dairy cattle, or dual purpose. And if they are dairy cattle, you have to look at calves, you have to look at all the different ages. So the subcategorization of these animals is what puts the difficulty here. And you need to know the population of what? The cattle in the state. And you know Ghana here, anytime you want to do census of any animals, we are going to face a lot of challenges because the farmers might think that you are going to use that to tax them. So they will, if they even volunteer to give you the data, they will underdeclare the number of animals. And you know here also, people think that when people know that they have so much animals, they may think they are rich, and then their responsibility will increase. So these are some of the things that make the estimation using the tier 2 a bit difficult. But nevertheless, we've been able to achieve a lot with this tier 2 method. So for the tier 1, as I said, it's very simple. You need to know the number of animals that you are using, and then you just try to get that by multiplying that with emission factors, which are already established by IPCC. So you get the population numbers, and then you multiply it by that. So this method is mostly useful for initial estimates of greenhouse gases from livestock. And then they provide countries with a standardized and accessible way to estimate greenhouse gas emissions. So here you can do that for all countries. So it makes it easy. If you don't have specific data, you can just pick the already established data and then use to do that. And this can also cover both enteric fermentation and then manure management. So for the enteric fermentation emissions, they are normally estimated by multiplying the number of cattle by the global average of emissions. So using the emission factors, and that is what is going to help you to get there. But we have to know that the emission factors differ based on the type of animal, whether it's cattle, sheep, or goats, or the subcategorization of the animal. For manure management, emissions are calculated using the standard manure production values. And then, and these are then converted by using the factors that I mentioned about. But one thing about this procedure is that even though it can help you to compare between countries, it only uses basic livestock populations, and then it's try to underestimate how much emissions that are available within the sub categorization. So it is the simplicity that we are talking about here is based on the fact that it is standardized in terms of how it is reported. So you can pick values from one country and then use that emission factors to calculate for another country. So because of that, it is inaccurate in reporting specific conditions within different countries. So regionally, you may have issues. So even in Ghana here, there are different ecological zones. So if you are relying on the tier 1, you may consider both the Guinea savanna, the forest zone, the transitional zone as one. Meanwhile, the conditions over there are different, and that means that you have to consider that differently. So based on this limitation, then the tier 2 procedure was instituted. And this procedure tried to do that based on country specification. So every country is tasked to produce their own estimates for these gases. So for enteric fermentation emissions, this uses local data. So you can't just pick data from anywhere and use. You have to generate the data internally and use that. And it also have to consider the type of animal that you are using, whether it is raised intensively, whether it's raised extensively, whether it is for milk production or meat production, and then the feed intake, as well as the composition of the diet or feed that you are providing for the animals. So for manure, using the tier 2, you have to consider local storage systems and climate-specific methane conversion factors. So every specific area, you need to generate these conversion factors to properly estimate the methane emissions. And this is more flexible. So it gives us room to sometimes use expert judgment and so on and so forth to get the estimation done properly. So this procedure is more accurate compared to the tier 1, and it accounts for both extensive system and then intensive system. All the system of productions are accounted for. And because of the fact that it is country specific, it is more credible in terms of the data that is generated from there. So here, it captures the emission reduction from improved practices. So for example, if this year, these are emission factors that you got, and then farming practices have improved and conditions have improved, you have to go back and revise. It's not static that once you get these factors or this emission factor, then it is static and it's going to be forever. You have to review it over time once conditions improve. So because of that, you can create a tracking tool to be able to follow and then make adjustments as and when conditions improve. So it helps us to target greenhouse gas reduction by focusing on policy, because when we explain how these contribute to emissions, we can try to bring out practices that would reduce these emissions. Once we bring out proper practices that reduce emissions, then we have to go back and then update the values that we have. So for the mitigation strategies, we are looking at using the regenerative practices. So in livestock production, when we talk about regenerative practices, it might not be the same as what happens in the soil or crop side. But here we are looking at addressing dual challenge of one, reducing greenhouse gas emission, and then enhancing carbon sequestration. Because if we are reducing greenhouse gas emission, we also have to try to improve the carbon storage so that the plants that the animals will consume also grow well, and then they can get good forage. So it has various combination of factors that it uses. It's approach livestock farming in multi-dimensional way. It looks at land management, manure handling, and then the use of advanced innovations. So how do you manage your land? Are you using crop rotation? Okay, are you using land rotation? Whatever procedures that you are using, that conserves soil moisture. The idea, soil moisture and nutrient, the idea is to limit the usage of synthetic materials as much as possible. So here we are looking at synthetic fertilizers and the synthetic chemicals or pesticides for controlling pests and other things. And when these are properly done, then to pave way for sustainable and climate resilient livestock sector. So here, even though we are animal specialists, we are also
sensor data, and then we can also collect satellite data as well. So we have the sensor data, we have satellite data, we have drone data. We put all together, right? We call it data fusion. We put that together to make meaning out of that, right? Okay, so what are some of the things that are detected? We'll be looking at cover crop, so that's crop cover detection, canopy temperature. We have biomass persistence in a particular area, or changing biomass, and then tillage patterns as well. All those things can be monitored in continuous time. If there's any undesirable change, that can be mitigated early before it becomes a huge problem. So, looking at what some of these MRV practices, so you monitor, you report, and then you can verify or validate. That has been done across Africa, has proven to have very good results. We've collected, over Africa, different projects have collected a lot of data. So over 10,000 plus field measurements, right? And then we've used different AI architectures to look at carbon stock prediction, sequestration rates, greenhouse gas flux forecast. So none that, and on the average across Africa, when we look at soil carbon prediction, we have a very high outskirts score. I think everybody has done some statistics here. So an outskirts score of 0.92, which is what, that means the correlation is very good, right? Meaning that when we collect enough data, I think, was it yesterday or this morning, we are talking about having a lot of data on Senodo that everybody should contribute. Right? Now, to be able to do a lot of prediction, you need a lot of data. So I'll add my voice to Prof. Vincent. So those who have not contributed, right, for these models to work, they need a lot of data. And as we collect a lot of historic data, as all the historic data you have, if you make it available together with everybody's data, we can have better prediction. So let's look at a case study in Zoya. I think if there's any Kenyan there, I hope I have pronounced it correctly. It's called the maize basket of Kenya. So they have deployed this sensor networks, and they give carbon credits. So, since they started monitoring, there's been 18% improvement in soil carbon, right, retention, and then there's a 32% reduction in greenhouse gas emission. Okay, thank you. And a whopping $2.4 million in carbon credits. I think that's since 2014, right? It may look small, but this money otherwise they wouldn't have had, right? So so they should tell us that once we move in that direction, right, there is also money for the farmers, right? Not just for those providing the solution, the farmers, for everyone. So what we need to move from taking data to action. So we have the full sensors, we collect data, we do cloud analytics, we can also do edge analytics. Then we use the AI for prediction, we get insights, then the farmers act on the results, right? So that's why we need continuous monitoring. Then when we have this, then we have to democratize access, right? So we say what access should be free, generally. So we have to have, in Africa, generally, you know, our official languages are not our mother tongues, right? So if you are developing apps, in Ghana, we just don't develop them in English. So as a lab, we also have apps to help the farmers do weather forecasting and things like that. We call SIWA, Smart Indigenous Weather App. And the farmers contribute data and they have responses in their local languages, right? So we have to democratize access to this so that farmers can use. And we also keep developing low-cost sensors. Sensors from the global north are quite expensive, and I also use us as a lab. We are also developing sensors for to monitor, to measure, what's the name? Heavy metals in water, right? And I believe once it's ready, some of you can purchase them and help in further development. And to improve research, right, we also need to open source data. So once your Zenodo is fully populated, Zenodo is already open source. So I believe once the data is available, models will be built upon it and we'll have better prediction. And we also talk about partnership. So we are here, we are always open to partnership opportunities as well as DEPA Lab. Okay, so in terms of impact, I mentioned one, that's the deployment reach. There's also financial impact, market growth. I'll skip that and then end because I can see it's almost time. So I'll simply put that the soil can speak and AI helps us listen, interpret, and act. So through this, we transform agriculture, fight climate change, and empower African farmers. Thank you.
Thank you very much. Just in time. Thank you very much. Questions? So we will start with the lady. Johanna.
Thank you for your interesting presentation. This technology sounds really promising. So you said that monitoring with these sensors is 1/10 of the cost of normal measurements, and that you implemented 125 sensors in your case study. But how much does one sensor cost? Because it's probably really pricey to implement this technology.
Okay, so, well, this is not my work. This is from the Kenyan state, I mean, the county, state. So I'm reporting their work, right? So because of the cost of census, I saw my scientific directors hand up. So let me use census for heavy metal measurements. Then I have a problem with Galamsey. So our waters in some of these areas are contaminated. And if we have to do continuous measurement, those sensors are quite expensive. Some are in the thousands of dollars. So what we are trying to do as a lab, but we can't deploy them. They are too expensive. So we are trying to develop sensors less than $100. So that's what we've been doing.
Mine is a general concern about super AI. I read that there are a number of petitions against the development of super AI because of the fear that it will suppress human intelligence. In your field as an AI specialist, what is your take on this?
Well, the AI system is also developed by human intelligence. So there's always evolution. There are pastors who say you should not read your Bible from a tablet. Right? So, as systems are changing, humans evolve. So there may be some basic acts. If, if you have a washing machine to wash your clothes, it also made you lazier. It's made you more productive because you use that time to think of other things. Right? So I don't think AI will make us lazier. Yeah. That artificial general intelligence, right? So basically, trying to say it can do everything, think like a human generally. At the end of the day, AI only it is generative, but it only generates what you have taught it. It puts what you've taught it together to generate. So at the end of the day, I would say, whatever the case, as AI does some, we have spare brain power to use for other things. Thank you very. Oh, sorry.
Alone, I think it was also in connection to Johannes' question on the MRV for carbon and other stuff. Already, Deeper Lab is liaising with CSIR Crop Research Institute. And with UK, 2 institutions, Sonar Vision and then the James Houghton Institute, we are coming out with a real-time monitoring device for carbon. Some of these sensors have even been trained to have sensor eyes to be able to see their environment. Because sometimes farmers tell you that if these things are there, it distracts their work, something like plowing and others. So as you are saying, some of these things, the idea is produce them at a cost lower than $100. And then you are able to take some of this data in near real time, sometimes at 30 seconds interval. So you just have to imagine that you are taking this data for about 6 months. You have thousands of data sets to be able to make massive decisions. So, yes, it's a very good deal for just $100.
But I think carbon changes will be not happening in 3 seconds.
No, for sure.
Yeah.
Thank you very much, Chair. So you make a point on democratizing access. Thank you. So it's, for me, I think it's contentious in the sense that this is my personal belief, right? I know it goes against what Prof is doing. This is what I've realized. Most funding mandates require us to open up our data sets as Africans, right? So most of our data sets are online, easily accessible. But usually it's difficult for us to come across data sets from US, from Europe. And so the open access mandates, in my view, only applies to us. So in my view, we get a funding, we make it access, and developers outside get access to it. So when you made the point on democratizing access, I just pointed to Prince and said, does this man believe in what he's saying? Because they said data is the new gold, right? And all this gold, you are democratizing it. But we preach open access, but should it be a restricted democracy? Let me say, is it authoritarian democracy or something like that? Is that the way to go? Opening up all our data sets without having any competitive or development